Hey class, just wanted to go ahead and keep moving forward from where we left off yesterday. We talked about using a thing called U-Substitution. Again, U-Substitution right there. We talked about already how to deal with the original integration of adding 1 to the exponent, dividing by the new exponent, and then if it's an indefinite integral, we add plus c. If it has an a or a b, we go ahead and do f of b minus f of a and work it out. And so here, this is the part where it gets a little bit different, a little bit more work to do, because we're talking about, again, like we said yesterday, talking about chain rule, the chain rule. So derivatives, we did chain rule, and we said, okay, that's the derivative of the outside times the derivative inside. But again, keep the inside portion there, don't touch it. Now, we talked about before, or yesterday, that we should have an inside and an outside. And if we do the derivative of the inside, it should cancel out something on the outside of it. So that way we can actually do the integration and everything. So if that doesn't happen, if we cannot actually find like the derivative of the inside here to get it to cancel out with that or something, then that means that we don't have U-substitution happening. And again, like we did last time, we said, okay, well, this is our inside portion of it. Because if we take derivative of x squared minus 1, that would be 2x. And 2x matches up with that 2x. And then later on, we will go ahead and do some work with that. We said again, with this one, this part was the inside. So we took derivative of x cubed plus 2. That would be 3x squared, which matches up with that. And then this last one here, we were saying, okay, well, if that was the inside, take derivative of it, that would be x squared minus 5, which is 2x, which is not the same. That's not the same, so therefore that would not work. These two would, this one would not. So when we do that, we know, okay, with this part here, since they match up, we can do the U-substitution part for it. And now here are the steps for doing the U-substitution. And so here it says, first off, identify the inside function, which that's what we did up top here. And then let that be your u. So we'll say like u equals x squared minus 1. Right? And then from that part, we'll find du. So in other words, take derivative of u, which makes it du. And then take derivative of the other side also, the other side there. And since it's with respect to x, we do dx. And then we're going to solve the equation for dx. And then we're going to substitute the u in and du. And then go from there and cancel stuff out that we can. Then we integrate it. And so, so it says substitute the du and du. Any extra parts that should divide out, or you will have to account for them. Move any multiplied constants to the front and integrate. And don't forget the plus c if you have an indefinite integral. And then substitute your original inside function back for the u. In other words, don't have u in your answer. Substitute that. All right, so that was a lot of steps there. We're going to go through this really quick, and you'll be like, oh, that's not that bad. We got this. We can do this. All right, so I know I'm not going to have enough space there, so I'm going to rewrite this problem on regular notebook paper. And so we have the integral, and this is example 2. The integral of x squared minus 1 cubed times 2x dx. Now here again, this is exactly the same thing, same question as example 1, and all we're doing now is just going ahead and just working it all the way through. So first off, we said, okay, figure out what the inside is. So again, if I do this portion here, if I were to take that and take the derivative of it, it would give us 2x. So we would say, okay, that's your inside. It's your inside here. So that would be x squared minus 1. All right, and what I'm going to do here to help out, I'm going to go ahead and make this, since we're talking about u substitution, since we said u is this portion here, I'm going to make this u cubed 2x dx. All right, so now let's go ahead and take a look and work on the u portion of it. So we take derivative of u with respect to u. This will become du. or 1 du. Derivative of u would just be 1, and that'll be 1 du. Right? And then we take derivative of this side, that's 2x. Derivative of 1 is 0, so we'll just do dx, 2 dx. Take derivative, you have to have a du or dx. And just like before, we have the dy dx and all that good stuff happening. That's where it's coming from. So, and then dy dx, that would be something like du divided by dx there. Oh, yeah. All right, so here, the last part says, okay, well, when it comes to what we're dealing with right here, we have a u, we have an x, and a dx. But we're trying to do u substitution. So that means this dx has to be, in order for us to have the derivative, has to be du. And we have a du right here. So what we're going to do is we're going to have to do a little bit of more work here so we can substitute it in for this dx. So that way it gets the dx now becomes a du to match up with the u that we're dealing with. And it's probably a lot of stuff I just said that you don't really, doesn't make sense, but just keep watching, keep watching. All right, so here we're trying to get dx by itself so we can substitute something in for it. So here we're going to divide by 2x. And you're always trying to get rid of dx or get dx by itself. Always trying to get dx by itself. So we have dx equals du over 2x. Now again here, because we cannot have a u and an x there and find the antiderivative of it, integrate it, means we have to get rid of the x's and do with the u's, which is what we're doing right here. So here, what I'm going to do is substitute this portion back into the problem. So here, since we found out that dx equals du over 2x, we're going to do u cubed, keep the 2x. Now dx, we said, equals du over 2x. So we're going to do du over 2x. Right? We simplify things down. That part cancel out. Left with u cubed du. And now we're down to the easy portion where we're just going to add 1 to the exponent and divide by the new exponent and go from there, and then plus c. So here we would add 1 to it. And because it's an indefinite integral, there's no values for a or b. We do plus c here. And so here we would get u to the 4th over 4 plus c. But then the last portion is you cannot keep u in the problem by itself at the end. You have to change it back to what u was equal to. So u is equal to this, so we substitute that back in for u. And that's our final answer. And so our process will be the exact same each time. You're going to figure out what your inside is. Do take derivative of that. So you'll have a du in your answer and a dx. You'll solve for a dx. So it's going to be du over something every time. Then we come back over and we substitute something in for the dx. Whatever that dx equals, substitute that in. Get things to cancel out, and then go from there. Now, if we get to the point right here and something doesn't cancel out, that means we're just either did something wrong, we chose the wrong inside, or something's not going right. No, it's not integration by U-Substitution. So it might be integration by parts or something else. So with that, that's what we're dealing with. That's the first one. Now I'll come back and do another one in a few seconds.